So here at the cryolab at CERN, I'm gonna prepare an experimental setup to measure the low temperature properties of thermal properties and physical properties of thin film materials deposited on copper substrates. And I'm also gonna study through this setup how the substrate itself is affecting the low temperature properties of these materials. All of these in preparation for a possible employment of these materials in the construction of the SRF cavities for the FCC.
So I'm working with a private company in France to fabricate seamless cavities. So the cavities are used in the particle accelerators to accelerate the beam. We're using a new technology called electro-hydroforming, and the objective, or the way the technology works, is we create explosions with an electric arc in water. This explosion is then deforming a sheet of metal, and this sheet of metal, through expansion, will form the cavities. The goal is then to create the cavities without having the weld, which is not the best thing.
And my goal is to investigate the critical current, transport current of these wires, because there has to be a specific minimum limit for the critical current density. And for this I have to create or to design a machine that can measure the critical current in wheels, in tapes, in long superconducting tapes, from wheel to wheel and in a very fast way.
The valorization of the technologies that my colleagues are working on. So they're working on superconductivity and cryogenics, and I'm trying to, first of all, estimate the market size or the market valuation of these technologies, and then second of all, try to find different application fields, so we are able to lower the prices of the suppliers that will supply the materials for the FCC.
So I'm centered at the University of Siegen in Germany, and I will be working on the thin films, or forming thin films onto copper substrates. These thin films will be niobium tin as well as niobium nitride, and these thin films are basically going to be, or are foreseen to be used on the future cavities for the future circular collider.
Well, my study has to be a lot with trying to do thin films and thick films deposition of niobium into copper cavities. The idea is to use it for accelerating particles in the FCC.
I'm developing a special tool for testing RF properties of superconducting materials, which is called quadrupole resonator. And these materials can be used in different areas, starting from medicine and ending with future accelerators.
I'm about to study the architecture of cryogenic systems. I will start easy, so I will start from steady state, so the basic operation of existing cryoplants, and then try to simulate or model the systems in their transit mode, so cool down, warm-ups of non-existing systems at the end.
My goal in this project will be to design a turbo compressor for a helium-neon cryogenic cycle, and the main challenge will be to study the effect of different gas mixture, so different concentration of helium and neon, on the performance of the compressor.
My research project is about studying the magnetic and electric properties of niobium-13 wires and FGB2 wires. Together with that, I'm going to go deep inside even the microstructural features of these materials in order to get this, let's say, great goal of reaching the 16 Tesla magnets for FCC. So the basics is to find a new, feasible and working material, and the best candidate is niobium-13. Under this point of view, I will do my best.
So my project deals with the microstructural analysis of several superconducting materials for the CERN Future Circular Collider. And my aim will be to connect the microstructural properties of these superconducting materials with their physical features. And I know, of course, it's not easy. But I think that the better we understand the connection between the physical properties and the microstructural ones, the more we will be able to develop even new formation techniques for these superconducting materials.
My project is connected with the development of the neon-helium mixture cycle for the precooling of the main helium cycle of the future circular collider.